Hello everyone, this is Mirror and Nuts, and today we'll be continuing our beginner-friendly Road to SCP video series. Today we'll be looking at another HackTheBox machine, that is October. October is based on Linux and the difficulty is medium, so let's just get started. So first thing what I always do is I run an auto recon scan. If you guys don't know what auto recon is, it's an enumeration tool, and it's gonna do nmap scans at first on the target machine, and it's gonna give you the scan result, and based on the open ports and services found, it's gonna do additional scans on them. So AutoRecon is available on GitHub. You can get it from there. And so I'll be running this autorecon.py as root. So I'll be giving sudo over here. Another thing is, don't always rely on AutoRecon scans. Like 95% of the time it works great, but sometimes you have to manually enumerate things further. It means like this tool is always, it's not going to work. It's not going to give you the 100% output every time. Obviously the results what it gives most of the time is very accurate, but sometimes you have to manually enumerate things further. Okay, so that's out of scope for this particular tool. So we'll be giving Python 3 over here in order to run this autorecon.py file. We'll be giving the target IP address, that is 10.10.10.16 in the case of October, and I'll be giving the O switch over here for output directory and the output directory where I want to save the scan result. So I did already execute the scan, so let's just look at the scan results. And first thing what I do is I look at the full TCP nmap scan. So let's just look into it. We see that we have two ports open, that is port 22 running SSH and port 80 running HTTP. So what we'll do is obviously we look at the version number as well first, and if we see something present in searchploit or on exploitdb, we can probably go and check out for any exploits probably. But I think these late versions are like obviously not very latest, but I don't think there are any known exploits for these. So what I'll do is I'll just look into port 80 for now. Let's just go to our web page, sorry, web browser. So we come across some web page which says October CMS vanilla. Okay, so obviously here we have multiple things. It says account management, we have a sign in register. We can probably try to register over here first. So obviously just go around to a website and see what you get, something interesting or no. You have a forum over here as well, you have a blog over here. So another thing, obviously whenever there's a web application, it's must to have a GoBuster scan done. So what we'll try to do is we'll just try to use GoBuster, and will be before GoBuster will need a directory list, right, word list. So we can probably locate the small txt, or we can use this small txt or the common txt. So let's just go with common txt first, because it's like very short word list, 4,000 words, and small txt is around 80,000 words, so it takes a lot of time if you add extensions and everything. So let's just look at common txt. I always use common txt first, but now I'm starting to use small txt first, because since it's 8,000, I increase the threads, the scan is considerably faster. But yeah, you can use common txt first, and let's just look into the, yeah, so this is the one which you're looking for, common txt. If we cat this and we see, obviously these are the directory names which are going to be, GoBuster will try to fuzz over here, like probably like test1 directory, test2 directory, something like that. So this is not like a brute force attack, but we are giving a word list, so we are checking for those directories and names. So we have the common txt now, so we'll be running GoBuster. So we'll be using GoBuster over here, dir for directory mode, directory scanning, uswitch, that is for URL, my bad, and we'll be giving the, I just hit enter by mistake, so 10.10.10.16 is the URL, and also we'll be giving the word list, that is common txt. Also don't forget to give extensions, that is x, switch, and you can give like probably php, py, pl, sh. Since it's a Linux box, so we can give all these Linux based extensions. We can give txt, html, and cgi probably, and also we can give the output directory, that is GoBuster 80 common txt, something like that. Okay, so I think so let's just run this, and you can even give the threads, so that is t, that is number of threads it will run. By default it's 10, so we can probably give like 40 or something, and we can run the scan. So it would probably take some time to execute this. So I think GoBuster already did the scan, because for me sometimes GoBuster scan works, sometimes it does not work using the AutoRecon. Sorry, my bad, AutoRecon does the scan. So this is the AutoRecon scan. I guess I did not additionally do it, so it used the common txt, somewhat similar word list as common txt, and we get these scan results. Okay, So another thing, just small thing over here, if you do not get anything in common txt, go for small txt scan. If you do not find anything, go for medium txt scan. Okay, so this is how you can go. Probably you can use big txt as well later, but I think that would be too much. But yeah, you can follow this hierarchy, like common, small, and then medium. Okay, so we get multiple things over here. Obviously, when I did the box for the first time, I'm going to check out for all the things present over here. Okay, but let's just look into this backend directory now, because obviously this thing, like, we can probably go and check out for each and everything. Index.php would obviously be the same page over here, and accounts as well, as we saw. So let's just look at the back end, because obviously, since it will probably take a lot of time to go and check out each directories over here. So let's just look at the backend directory and see if we get something. So we come across some login page. Okay, so probably it looks like some admin login page over here which says like October and getting back to basics, sorry, my bad. So what we can try to do is we can just try to Google for default credentials. Okay, obviously we have some login page over here. You can probably test out for default credentials like root, admin password first, or we can just go and Google for October CMS default credentials. So let's just go into this October forum over here, and it says like the default credentials is admin itself. So let's just try that and see if it works. So it did work over here. Okay, so that means this web application, the default credentials were not changed and it was present itself. So we are over here as user admin, I guess. So obviously when you come across this page, it's like somewhat like what we saw earlier. Okay, so if we look into this web page, you have this blog, forum, and all these kind of things, right? So probably we can manage this page, okay, like this particular page over here from this particular backend. So what we'll try to do is let's just look into it more and see if we get something. So if we obviously, when I did the box, I was trying to manually enumerate things, and I found something like media over here, and I found upload functionality. So obviously first thing in mind is upload functionality. That's one entry point. You should always remember, try to check out probably image file or some file present over here. So when I clicked upload, obviously we see that we have this dr php page running over here. Okay, and also over here we get a hint that PHP is running, obviously, because we have index PHP file loaded over here. So index PHP is nothing but, just to avoid confusion, it's nothing but this particular page itself, the default page over here, October CMS vanilla. So this is the default page itself. So obviously we know PHP is running, and it says library dr PHP 5. For some reason there's PHP 5 over here, I am not sure. So obviously we can upload something. So why not try to upload a PHP file itself, right? PHP reverse shell. So you can get it from Pentest monkey, PHP reverse shell. So I think, yeah, this is the reverse shell which you're looking for, and I already have it downloaded in my system. So let's just look into that. So this is the shell which we are looking for, and what we need to modify is over here is, obviously if you download it, this is the same thing which is going to come up, right? So I already have it downloaded. You guys can go and download it from there. So we have this IP address. Obviously I want to modify this IP address to my attack machine's IP address. So attack machine is my Kali machine. Okay, so the one which I'm working on, this machine over here. So I'll just change the IP address, that is 1428, because that's my IP address. Your IP address may be different according to HackTheBox VPN connection, and the port is mentioned over here, so I'll just give port 4444. That's it. You do not have to give anything else. Probably here you can enter bash as well, but at the first I just leave it as sh. Okay, because some boxes have issues with bash, I guess, so I just leave it as sh, and probably when I get a shell I can upgrade it further. Okay, so this is what the file looks like, and this is what I want to send it. So what we'll try to do is let's just rename it to something smaller, maybe probably like reverse PHP, and we can upload this particular file over here in media. Okay, so what we'll try to do is let's just upload this reverse PHP file, and it says error uploading file. So obviously first thing I was like, okay, I tried to upload, I could not upload, but I see something over here, like this was an actual hint for me. Other thing is you can just check out the source code of this particular media page, and you can see what's stopping, what's denying that blocking, because on Google I think it's available, I'm not sure. but not the source code entirely, but actually some part function of it is available, I guess. So obviously I saw PHP 5 present over here. So what I did was, obviously I just renamed this to PHP 5. Okay, we have this over here, and I upload this file again, and it says upload complete. So that means we successfully uploaded. Now obviously we need to access it as well, right? So obviously we go over here in this drphp which was present long back. It says public URL is this, and reverse PHP public URL is this. So before clicking that, what we'll try to do is we'll just set up a netcat listener. We'll just go to cd exploits first, and then probably cd exploit directory. Okay, then we'll set up a netcat listener on port 444. If you guys don't know what netcat is, NC is. So NC is like, a connection tool which you can connect to the target machine and your attack machine. Obviously many of you guys may be knowing, but if you guys don't know, it's like a connection tool. It's going to set up a connection so you can communicate from the attack machine to the target machine. So we'll be giving the N switch over here for numeric IP address only, V for more verbose entries. We'll probably get more information over here. We'll give L for listening mode, and P for the port number, that is 4444. Why 444? Because obviously now reverse shell over here, which we have now uploaded over here, the port is 4444. Okay, as you can see over here, it's 444. So obviously it will try to, since we have uploaded the file, so this will initiate the connection and we are going to receive it. So that's why we are having this listening mode over here. So let's just see what will happen. And just to make things better, what we'll try to do is, let's just do this particular thing over here. Let's just click this, public URL and see how it works. And we immediately get a shell over here. Okay, so obviously it was very fast. Otherwise it takes like, for a few seconds of loading. So we get a shell over here, and this was like this user access was very easy. Obviously get the default credentials, upload it, and get this particular page over here. So if we see over here, we have www data over here, and let's just go to the home directory. We are obviously, it's my bad, I used dir, but it's worked. cd harry lsla, and we have this user text over here, and we can very well read it because we belong to this others group over here. Obviously I just use it that way, like user 1, group 1, and others direct. So I just use it that way because it's easier to understand, right? User 1, group 1, and this others. So we belong to this particular group because I don't think we belong to groups Harry as well. We belong to this www data group, so we can very well read this user txt file. Okay, so we get the user flag. So this was the easiest part of the box, because after this it is somewhat tricky, and we'll look into it how it is done. So let's just go to the TMP folder for now, because obviously when I come into the box, I check out for sudo L, nothing is present, and I check out uname as well, just to see the OS what it's running. So probably it's running like a 32-bit OS over here, and you can check for kernel exploit, but I don't want to go that route, so let's just avoid that. Because in Linux box, I guess in HackTheBox, I don't think there is any kernel exploitation intended method. Okay, so what we'll try to do is, let's just go to cdtmp, and let's just go to the tmp directory, and let's just try to get linenum from our system. So what we'll try to do is, we'll just create another let's just locate for linenum first. So linenum, you can get it already from your from Google. You can just search for it and you can get it on GitHub, I guess. So linenum, if you don't know, it's an enumeration tool. Okay, so once you get user access, like our auto recon was for the initial access, right, when we do not get user access. So once you get access to the system in Linux, you can run linenum or linpiece and get additional information over there. So we did copy it to our exploit directory. So we have linenum over here. Okay, so now what we'll try to do is, we'll just try to set up a Python HTTP server. So we can give Python 3 M for module switch and HTTP server. So you can just hit enter, and by default it will give you 8000 port. If you want to give some different port, probably you can just after server you can enter that port number. So we have HTTP server running over here. Let's just check if we have wget. Yes, we do have wget. So what we'll try to do is, This is the target machine left side, that is the October box, obviously, and this is my attack machine over here. Okay, I'm hosting the HTTP server. So we have this Linenum file, right? I want to transfer it to my target machine. So obviously I'll be using Python's HTTP server and wget. So many of you guys may be aware, but still, since beginner friendly video, so I'm just trying to make it simple. Okay, we have the IP address, that is the attack machine's IP address. My Kali machines, don't go with this 00 because it's hosting on localhost, right? So local server. So that's why I was mentioning that. So don't get confused over here, because to this target machine our IP address is this. Okay, so which we can see in IP config, or sorry, IF config or IP and space A. Okay, so this is the port which we are going to give, and then we'll be giving lin enum.sh. Since we are already in the tmp directory over here, we can probably just enter this as well. Like, we do not have to enter the O switch, so it will just get downloaded into a tmp directory since we are already present over there. So let's just check if the file has come. Yes, it has come. So let's just give execute permission. So we can give chmod, we can give 777, or we can give 755. This is 5 as of now, because read is 4, write is sorry, it's not 755, it's 76. So read is 4, write is 2, and execute is 1. So probably you can just enter 766 for now and see how the permissions would change. So all these things have to be hard coded in your head. Okay, so the read write permissions and everything, so you should not forget any of these things. It should be like muscle memory. You just know it. Okay, so now if we look into this LSLA and we see over here, so we have read write execute and read write dash dash. So we just change this execute bit, so that's why we added 7 over here. Okay, so now we have execute. What we'll try to do is, let's just run this linenum for now and see what we get. So obviously this may take some time, and obviously we got the get request over here from the target machine. Target machine's IP address is this. Okay, so when I'm doing the box for the first time, obviously I go and check through each of the things over here. Not obviously, it may look, a bit too much at times, like a lot of things present into this to digest, but obviously I just look into important things. Obviously the distribution release also is very important. Take this, copy it, and paste it in search exploit and check for any known exploits for this particular release version. Okay, and then probably we check for groups, sudo l, and also probably check for any cron jobs. You can even run pspy as seen in my earlier videos, previous videos. So obviously we have the process over here. Check out for any processes as well. If there are any process which is running as root, and probably we have some file writable access or some access which we can connect to, something like that. And obviously you can check for multiple things over here. I know it's a huge list, but you can probably check. And what's interesting over here is, sorry, another thing is, when the box is released, right, you'll probably get a date when the box is sorry, not released, but when the OS was set up and everything. So probably you'll get a tentative date from the user flag and everything, and even the location on top, kernel information on top. So what stands out is that this particular May 17, 2017. Okay, so probably somewhat around that time something would be interesting, probably, because obviously you can check out on top as well if we saw for the user flag and everything. And also if we see over here, we have this April 21st 2017, there is some binary install. Obviously I hope you guys know what SUID files are, right? So set UID files. So what this would do is, in short, if you guys don't know, since S is present over here, set UID is present over here in the execute over here, so this is the first group of owner, right? So that means this is root. So now we belong to the third group over here, because we do not belong to root user, we do not belong to root group. So we belong to this third group. What we can do is read and execute. That's fine. So we can read and execute, but when we'll execute this file is going to be executed as root user, because this S thing is present over here, set UID. So when you execute it, the set UID would be to root, and then it will execute this file. So in short, just to keep it simple, if you run this file, it's going to execute as root. since we have X over here, if we do not have, see over here, if you do not have X, right? So we can only read that file, we cannot execute it. Since we have X over here, we can execute it and it will run as root. Okay, so this file is particularly interesting over here, first thing, because when I did the box first time itself, I saw this thing because I look out for any date variation and any non-standard binaries which are present over here. So we have this user local bin overflow. Let's just take that and try to run it. So first thing what I did was I tried to run it and it says syntax this plus some input string. So first obviously I thought that, hey, you know what, let's just add this and add who am I and see if we get something. Nothing. So I tried to play around with it, I tried to run some file along with it, but it did not work. So in short, the name as well, it suggests that, you know, it's overflow, so somewhat like a buffer overflow probably, but we have not yet confirmed it. So what we can, I think file is present over here. Yeah, so file is present and over here it says 32-bit executable, some Intel version and everything. Okay, so set UID ELF 32-bit, that's it. Set UID because obviously it's a SUID file. So we do not get anything interesting over here. So what we can try to do is we can just use strings. I hope strings is present in this box. So we get multiple. So strings is obviously, you know, because since this box, I don't know, let's just try to cat it first and see the difference. Because we'll get a lot of non-readable characters, okay, over here. So we'll get a lot of these things. So I just want to make sure that, you know, we can get, if you use strings, so strings will not display all these things. The string would display, you know, all this readable ASCII characters. So that's why I use strings over here. And we get this particular entire list over here. You can go through it and we see list str copy is present as well, which is, you know, very famous for all these buffer overflow attacks and everything. So probably it looks like it's buffer overflow. So what we'll try to do is we have this file overflow present in the system. We can try and send it to our target machine, and for that we can probably use netcat over here. We'll just close this because we need to use nc now to send the file. So to send the file from target machine to the attack machine, probably we can use nc over here, but first we'll just set up the listener, that is nc, and we'll be using nvlp port 5555. Don't use 444 because this thing is already running on 444, and we'll be giving the output switch to save the file. So that is probably, I think it's overflow, right? Overflow. So let's just save it as overflow itself to avoid any confusion. So let's just start this up. So now this sign is output to overflow. So you will get something, or just to keep it simple and understand, I know it may be confusing a bit at first. So what we'll try to do is we'll get some file in this connection, right, and we'll output it to this overflow file. That's why we'll be giving this right side switch. And over here what we'll do is we'll give nc 10 10 14 28, that is the target attack machine's IP address, and the port number 5555, same port number, because otherwise it would go to somewhere else and it will probably get some denied error. And we'll feed in the file now. We need to feed in the file into this IP address and port. So that's why we'll be giving this this thing over here, and also we'll be giving the file name, that is the entire path. Don't give overflow here because otherwise you'll have to be in this particular directory. I am sure most of you guys may know, but just give the entire path over here, hit enter, and we get the file immediately. So we have that file in our exploit directory. Why I got this file is because it was a bit hard to understand over there, so probably we can check it out more over here. So we have the overflow file. What we can do is we can check for overflow. Again over here, it's obviously the same thing except for that set UID, and you get some information. You can use Jira to check out what content is present over there, but obviously it's going to give that str copy and all these kind of things. So obviously we know somewhat buffer overflow may be possible over here. So what we try to do is, in order to confirm buffer overflow, what we can do is we can call this particular binary and we can give an input, right? So when you hit enter, okay, let's just clear this out, clear active terminal, okay, I'm not closing it, it's just going to clear that data which is present. So what we'll try to do is we'll just run this. If we just don't enter anything, it says like this plus input string. So you have to probably enter something over here. So what we'll try to do is let's just write some string So when we write some string, it does not give anything. So if you guys know buffer overflow, and I'm sure you guys are practicing buffer overflow, if you all are practicing for OSCP, because that's the 25 points in the exam, so probably you should know buffer overflow by now, and at least what it is. If you're not yet practiced it, that's fine. You can probably practice it later. But if buffer overflow, if you enter a long string value or something, so that means the buffer will overflow. Obviously, like the memory will, you'll write into some other location. Okay, so that's why buffer overflow happens in the first place. So it happens if you give a huge chunk of data, okay, a huge amount of data or something or some string, so that it overwrites the other memory location or something like that. So that's what buffer overflow is about. So obviously we'll just try to give a huge string over here first to see if buffer overflow actually is present. And if buffer overflow is present in Linux, it's going to give you some segmentation fault error or something. So what we'll try to do is, before this, we'll try to execute a file, like probably we can enter Python 3, since we have to give a huge list, right? So we can give Python 3, or we can give Python itself. We can give the C switch over here, and we can just enter print. So Python 2 and Python 3, the syntax is different. Python 3 you'll have to use this particular things, and in Python 2 you have to use without this brackets. I think you can use it with brackets as well, I'm not sure, but yeah. So probably what we'll try to do is we'll print a number of A's, okay? So we'll print A's into 100. So if we print this, let's just look at the output and see if we get something. So we get like 100 A's over here. So if we just do 200, so we printed 200 A's over here. So in short, it's saying print. So this is the Python, we are giving this tool name, right? And we are giving obviously the C switch to run this command. So print, and this A over here, which is present in these quotes, into 100 would print A 200 times. So obviously we can use this over here to enter over here in this overflow file. But now if you have to give this particular command over here, it's not going to work. Okay, I'm going to show you how it works. And you can give 200 for now. If you do not get the buffer overflow, try with 2000 maybe, or 1000. But let's just start with 200. So what we'll try to do is, let's just copy this. No known way, okay? So when I did the box, obviously I did it for the first time. Obviously I'm thinking, oh, it may be 1000, it may be 2000. So that is not necessary, but I know 200 is fine. So that's why I went with it now. So what we'll try to do is, let's just run this user local bin overflow again and paste this. So that's not going to work for you, because this overflow is going to consider this as a string. It's not going to execute it. In order to execute this particular thing, you have to probably enter something like this thing over here. So this $, and inside the brackets you have to enter this. So that means bash will first, because you're using this, bash will first execute this thing. Bash or sh is going to execute this thing first, and this value, whatever you get, probably you'll get like around 200 A's, that's going to be supplied to this overflow file. Okay, so this comes very handy, this $, thing. So let's just look into that. So let's just paste this, and let's just paste this as itself. So now if we hit enter, we get a segmentation fault, code dumped. Okay, so now if we take 100 in same place, but I don't think we'll be probably getting some buffer overflow. So let's just try that. We do not get anything. So probably buffer overflow is somewhere between 100 to 200. You guys can go and check out, like probably check out for 180, 160, 140 and so on. But that's not the right way to do it, right? Because that may take a lot of time to actually execute and know the location where the buffer overflow happens, like after how many characters. So what we can do is, since we already got this file over here in our attack machine, we can use GDP over here. So GDP, it's like an immunity debugger, and also there's a module called PEDA, that is like Mona Py, I guess. For Windows how you use it, right? So that way this is for Linux, and you can go, it is not present by default in your attack machine, and that's why, as I mentioned earlier, so this part is a bit tricky, this privilege escalation, but once it's known, it's easier to understand. And obviously this box as well, it was added later on in the TJ nulls list, but it is good overview of the Linux buffer overflow. So that's why I'm doing it as well. So we see we need GDB. Okay, so you can probably go and check out how to install GDB only on Google. You can get it, and also you have to install GDB PEDA, I guess. So PEDA PEDA. So you need to install both of these. So you can go on Google and they'll show you first install GDP, then install that PEDA binary or some module. Okay. So let's just run GDB. So in order to run GDB, you have to write GDB and you have to execute that overflow file. So before that, we need execute permissions on that overflow file. I don't think we have that. So let's just do that. So we can get 744. So obviously we'll add chmod over here, 744, and we'll mention overflow over here. Okay. So we have overflow over here. So let's just check out we have execute permission, because if you do not have execute, you'll run GDP and later on it's going to give an error that you cannot execute permission deny. So that's why make sure you have this execute. Obviously you can check it out later as well and try to change the permission, but yeah. So sorry, GDP, and we'll be giving the overflow file over here. So we have this overflow file present over here. What we can do is we have this overflow file, right? So what we can do is we can first try to check out okay, few things over here. In buffer overflow, the simple buffer overflow, you write a memory to the stack. Okay, so if we consider something like so if you have something like, okay, let me just check. Okay, so in simple terms, let's just look into this part later. Okay, so in simple terms, my bad, just close this. So in simple terms, when you're writing buffer overflow, I'm not going to draw the exact details over here, but just to make you all understand how buffer overflow works is, so this is the intended part for the memory to be in. Okay, so memory has to be over here. So buffer overflow, you're writing something, you're writing A's, A. So now the location, it's enough, but you're giving additional A's, like how we give 200 A's, right? If we had given 100 A's, it would probably be inside, but since we gave 200 A, in a general scenario, not in this case, I'm just saying in a generic buffer overflow case, simple buffer overflow case, you will write the this particular input to the stack over here. Okay, you'll probably write it in stack, and probably how you can achieve buffer overflow is in the EIP. Okay, so that is your pointer address, which thing it has to execute next over here in the EIP. It's gonna be like execute this shell code. Okay, so this location probably you will give. So I know it looks a bit messy, my bad, but probably you will give like execute this shell code. So that means whatever thing is present in this particular stack memory over here. Okay, so let's just enter it, I guess. Stack memory over here. So this particular code will be executed. So this is what a normal buffer overflow, simple buffer overflow looks like. But what is there are multiple security measures for that. You can probably have DEP present. Okay, so and data execution prevention, and also you have ASLR present, address space layout randomization. So these two things, what it does is, firstly DEP, what DEP will do is, even if you write data over here, right, like you have written all these A's and all, probably you have written some shell code. So shell code as in some reverse shell code. Okay, so probably let's just delete these things over here. It may be a bit confusing, but yeah, this is a stack and you have written some malicious shell code over here. Okay, reverse shell, probably just enter reverse shell code, reverse shell. So what this DEP would do is, even if you write reverse shell, and in a normal scenario, like how are you going to enter, you're going to enter this particular stack, right, to execute this particular reverse shell. It's not going to work if DEP is enabled. DEP says that data execution prevention, so that means do not execute anything, any command or any code from the stack. So that means DEP would avoid this. Okay, and there comes ASLR as well. So we'll look into ASLR in some time, but yeah, this is what DEP looks like. So in short, it says don't execute anything from here. So that means our simple buffer overflow would not work. Okay. So obviously we have this GDP peda over here. We have that overflow file. First thing what we can do is we can do a check sec. So it just checks the security measures and anything I guess present over there. So this is like a command check sec. So hit that and it says NX is enabled. So NX is not no execution. Okay, so NX is nothing but DEP. So this is what it is, DEP over here. So we can probably enter just write DEP over here. So that is probably NX as well. Okay, so we have this NX present over here, and also we have these other things present. Obviously these things are disabled, but we have like a rel row which is partial. So in partial there is something called the GOT, global offset table. You don't have to go into much detail over there. So it's in short, if it is partial, we have write access to GOT something. So in short, buffer overflow would work fine that way. So just that's it. If you want, you can go and read it more on Google. But yeah, since it is partial, our expert would work. So we do not have to stress more on that. So we have DAP enabled. We have to find one way to overcome DEP. So in short, we cannot write any command to the stack. I know this may be a bit too much information if you guys don't know about buffer overflow much, but I'm just trying to make it as simple as possible, I guess. But yeah, in short, we cannot add normal shell code, okay, over here. So now what we'll try to do is we'll try to create another we'll try to what do you say, redirect this particular thing. Instead of the shell code, we'll try to redirect it to some other location, okay, which will execute some function over here which is already present. That's not a shell code, but it's some system function or something. Okay, so we'll do that in some time. Probably we'll just check it out. So we got DEP is enabled. So that means DEP is a bad thing for us. Obviously, we cannot have that normal buffer overflow done. Another thing is to check ASLR. ASLR is OS specific. So we can check that over here. We can probably just do cat proc sys kernel. I think it was randomize space, randomize va space. Yeah, I guess that is. So if we do this, in short, it says like the value of this is 2. So ASLR value is 2. Okay, so what we know now over here is DAP NX is enabled and ASLR value is 2. So in short, since DEP is enabled, we cannot execute anything from the stack. So we cannot write a reverse shell code, okay, what we write in normal buffer overflow, simple buffer overflow. So, and we have ASLR value over here, that is, 2. What does 2 value mean is, 2 is that there is full randomization of the memory. So what ASLR is, in short, I'll just give you an example probably over here, okay. So we have some command which, let's just consider overflow command itself, okay. Overflow command, okay. So in short, since ASLR is present at 2, if it is at 1, there is less randomization, I guess. But yeah, if it is present at 2, so just consider this 0 meter, 100 meter, 200 and all these meters over here as memory locations, okay. So just consider this as memory location just to keep it simple. So that means obviously you have a memory location, right, in your Windows system as well. If most of you guys are using Windows as a base OS, so in that as well you'll be having C drive, like there's a location over here, there's a path present. So in short, obviously in the hard disk there's like there are sectors and everything. So obviously there's some location present where you stay probably at your home place. There's probably some address present, right? So that means there's a unique identification present that way. In short, in the memory as well, there are addresses present. So just consider for now, for this example, that there is some address present that is 0, 100, 200 and so on. So if ASLR is enabled, first when I execute this overflow program, probably it will start with on the memory location that is 300. Since an ASLR is enabled, we start it again. Okay, we run this program again. Now it will start at 100. If we start it again, it will start at 500. So in short, what ASLR is doing is it's trying to avoid, it's not letting us execute something properly. We'll get into this a bit more like when we do this box. But in short, ASLR is enabled, it's going to first start at this, then this, then this. It's going to randomize the memory, okay? If ASLR is disabled, it will probably start over here itself, memory location. The binaries or libraries what are being used. It will keep starting over here. If ASLR is off, that is ASLR is 0. But now there is ASLR is present, that is 2. So we'll just leave it as it is for now. We'll look into this first hurdle over here and then we'll look into this. So since DEP NX is enabled, we need to perform a attack that is return to LIBC. Okay, but before that we need to somehow get hold of that EIP address. Okay, there's EIP present over here. EIP. Okay, so that is present. We need to get hold of this EIP address present over here. So what we'll just look into this GDP peda and we'll try to run this particular file and we'll give that Python this multiple A's which we had seen earlier. So I think we can give it now itself. 200 A's we had given, right? So let's just try to copy that and see if this works inside this. Yeah, so it did work. So in short, now this may be a little, it looks a bit hard, okay, since this is a beginner friendly series and this box, it's very difficult, okay, so it was very difficult because this buffer overflow part. So I'm just trying to make it as simple as possible, but let's just see. If you don't understand anything, probably ask me in the comments, probably I can try to explain it. Okay, so we have multiple registers over here, okay. So we have this EIP register which is useful. Just ignore all these registers, not interested in those things now. We have this EIP registered over here, and EIP register has, what is present is this AAA. Okay, this particular thing is present over here in the EIP register. Since 32-bit OS, I guess, so that's why it's for this, what do you say, bytes itself. So we have AAA present over here. So this thing is the hex value of this AAA. Okay, in the memory obviously there will be hexadecimal values. Okay, so hex values in short. So we have this 414141 and 41 is nothing but it belongs to A. Okay, so now since we have given 200, it wrote the program, that's the EIP, that is AA. Now what we need to know is we need to know the location of EIP. Since you are given multiple 200 A's, obviously it wrote EIP. But we need to get this particular location so that we have control over EIP. So what we'll try to do is, we have two options. We can check out that, create offset and, yeah. So create offset, you can do that, and I think there's check offset as well. So let's just do this create offset, I guess. So that is 200. Okay, create help. Okay, my bad, that is pattern create. It's not offset, my bad, that is pattern create 200. Yeah, so this is what it looks like. So in short, we get a size. Since why we chose 200, because in 200 we got a buffer overflow, right? So we can use this pattern create, and I think there is pattern check or something, I don't know. Check offset. Pattern offset, yeah, it is pattern offset and pattern create, my bad. So we have pattern create over here, that is 200, and what we have is, this is non-repeating characters over here. So in short, what this will do is, if this particular location gets added over here, okay, into the EIP, so we'll use that with pattern offset, and we'll get the location of this particular EIP string. So we'll just look into it. Since we gave the non-repeating characters of 200, if you want, you can copy this entire thing, copy it, and we'll be using R to run this overflow program. Okay, since it's already loaded over here, right, in this GDP, we are running that overflow program, and obviously you not paste it, but you do not need to paste that entire thing. We need to paste this command over here. Earlier we gave Python, right, over here, run, and we gave 200 A's. So now we'll give this non-repeating characters. So now we get something in EIP, that is AA8A. So this is the location what we got, and this is the hex value of this particular thing. So what we can use is pattern offset, and we can give this particular value, or we can give this hexadecimal value. So let's just look into it. So we get pattern offset as 112. So this is the location which we can write the EIP. Okay, so at this location we are writing the EIP. So in short, let's just look into it. So EIP location 112, sorry. So we got 112 over here, and what we can do is we can also use the hex value pattern offset, and we can get this 112 location. So this pattern offset is present in GDP PEDA, but it's as a MSF module also it is present, and you can use it for the buffer overflow in OSCP exam. So you can use pattern offset and pattern create. So you can use these things. You can check it out there itself, but since we are already in the tool, we can use this particular functionality over here. So we have 112. It gives the same thing obviously over here. Both mean the same. Sorry, in short we got 112. Now what we'll try to do is we'll try to modify our Python script. Okay, let's just add one more, create a document over here which says buffer txt, just a normal file, and we can have all these commands present over here, so you do not have to write the commands again and again. So let's just take this command for now, and we'll paste it over here. Why I'm using another thing is mousepad. Why I'm using this mousepad over here is because this cherry tree sometimes in the codes, see, this is what it does. So this is not recognizable in your SH, like your shell, so it will give you an error. So try avoid using it, because once I was very stuck using this code over here and I had to actually read the command multiple times, then I got it right. Obviously this thing is present. So please avoid this. So that's why I'm using this thing over here. So what we'll try to do is we give 200 A's, and what we can do is we can add over here plus, and we can give B, and we can enter like probably 4B's. Okay, so I'll just show you all how this entire thing works. I think we can just have it just running it over here. My bad, did I not copy this entire thing? 4B's. Okay, yeah, so probably we'll need another print. Just try this with brackets. Okay, so we have, I think it worked earlier as well. No, it did not give the B. Okay, I think I did not copy pasted it entirely properly. Okay, so in short, okay, you can just remove this entire thing over here, and we can just remove this thing. And if we print this, in short, it printed us 200 A's, and then it printed out 4 B's over here. Okay, so 4B it printed out. So in short, this is what we have to do now in our Python this, so that we can probably write this particular EIP over here, that is this particular thing. So what we'll try to do is now we can just create Python this, and we can enter 112 over here. Why? Because we got that location over here, right, as 112. So that's why we'll create that 112, and we'll have 4B included over there. Why 4? Because obviously we need 4 bytes present over here in the EIP. We do not need more than that, because that's the location which we have, so we'll give that. So 4 bytes. We are not addressing anything now. Since another thing is obviously the buffer overflow file is present over here. Okay, this probably is a 32-bit OS, and this is my, like, I have a 64-bit OS, but I'm not doing anything except for finding that EIP value as of now. Okay, so let's just find that value, see if we are writing the EIP, then we can go back further into that 32-bit OS. Another thing is you can probably try to create another 32-bit Linux OS which is similar to the target machine, and try to run your exploit over there. Okay, with keeping ASLR off, and then turn on ASLR that way. So I'm not going to do that because let's just try doing it over here. Once we get to know it, we can do the location and we can check out that. Okay. So we have this 112 present over here, and we'll try to modify this. We have the script present. Let's just try to run this. Let's just close this for now. We have this thing. Let's just run again this overflow file, and now give 112 A's and 4 B's. Okay, so let's just run that. For some reason, I think this, yeah, this thing should be outside. Just run this. My bad. Yeah, so we did run it. We gave 112 A's and 4 B's over here. So if we see over here, EIP, we have 424242. So 42 is nothing but B, X4B, okay? So we successfully rewrite the EIP. So successfully wrote EIP. So in short, we have access over EIP. So why EIP is important is because it can point you to the shell code, or it can, since we cannot execute shell code right over here, since DEP is present, as seen earlier, DEP is present. So we cannot do that. So we can address this to some other function in the library, okay? So we'll look into that part now. Since we already got this 112 present, I don't think we need this GDP PEDA anymore running over here. So we'll try to check out things in the target machine now. So we got this thing, ASLR value, that is 2. So we obviously we cannot check this value, I guess. So if we do LSLA, so obviously we cannot edit this because we do have only read permissions. So we cannot write it, otherwise we would have made it 0 and made things easy. So what we'll try to do is we'll use LDD. So LDD is a tool. Suppose if you're running something, if you're running Python over here, and if you're giving some shell command, okay, so if you're running this Python and bash command and everything, it's going to use multiple binaries and, sorry, not the binaries, but libraries, okay, so it's going to use multiple libraries over here. Okay, because any command what you're running or any tool what you're running may use libraries which are present. Okay, that's why sometimes you get an error, right? This is not installed, that is not installed. So this LDD will show us, there's one tool called LDD, so that will show us all the libraries what this particular file is using. So let's just consider this file for now. So let's just copy this and let's just use LDD and use this particular file and use grep for LIBC. So LIBC is that attack which we are going to perform, that is return to LIBC when DEP execution is not available. You can go and Google on it more, but that's what we are going to use, that attack. So that's why we'll be using grep for LIBC, otherwise we'll get a lot of libraries, I guess. So let's just hit enter and we get something LIBC SO6, something like that. Let's just copy this entire thing over here into our cherry tree. LIBC. Okay, so this is what we get, and if you look closely, this is the memory location of this LIBC library when I executed this LDD. So obviously LDD tries to run this particular application first, and it checks out for all the libraries present as well. So this is the location which is present. Now since ASLR is enabled, it will give me a different value always. So now the value is different. Just consider these bits, okay, over here. So we have something different over here as well. See, this half, this is changing. 74 here, it's B4 here, it's CB. So in short, it's going to change every time. Why? Because of ASLR. As I explained it earlier, right? Buffer overflow first over here, second over here, third, then randomization. So this is how it's going to change. So what we'll try to do is, in order to achieve overcome ASLR, we can use a brute force attack. Okay, since the memory location is changing over here itself, there's a very small change in memory, so we can probably have a brute force attack done and we can achieve a code. And since it's a 32-bit system, so you can brute force it because the address change would be very small, like very tiny. Okay, so we have this thing present over here. We have LIBC. Now, in order to perform LIBC attack successfully, return to LIBC attack. In order to successfully exploit this LIBC attack, we need three things over here. Okay, in short, we need actually two things. That is, one, the system command. One is the the command which you're going to execute, probably bin sh. Why? Because you can get a shell immediately. And another thing is you can have the exit, which is optional, which I'll explain to you all in a bit. Obviously, you can check for return to LIBC attack on Google, and you'll probably get there are multiple PDFs and multiple references. You can check out that how it actually works, and if you read through it, probably as a beginner, maybe it may be a bit difficult to understand. So let's just go. You all can go through it and get a better overview of that. So in short, we run this LDD on this LIBC. It's gonna obviously always give you some different value. So we have the library name over here, which we had copied earlier in cherry tree, right? So now what we need in this LIBC attack, first we need system and we need bin sh. So now what we'll try to do is, if we look at the diagram, so I know this diagram is not very professional and it looks a bit messy, but yeah. So in short, what we'll try to do is, we have a EIP over here. So EIP is, you cannot get this DEP done. You cannot do that. What we'll try to do is, we can do EIP into a new stack frame, and we can point the EIP to a function present in the LIBC, that is system. Okay, we can do that, and to system we can give a command, that is this bin sh command. So that means system bin sh is as good as getting a shell. We multiple times we have used system commands, right, in Python as well, and if you do bin sh, we'll get a shell. So that's what we are going to do, and obviously when we terminate this, it's going to use this, we are going to give the exit command, so it will terminate properly. It will not give us an error or something. So this is what we are trying to do now. That's why we need these three things present over here. Okay, so let's just so we need system, then we need bin sh, and we need exit. So what we'll try to do is, we'll check out for the locations of these commands in the LIBC. Since these are the hexadecimal values in the memory, so in the LIBC command, we'll just look into the location of these system, exit, and bin sh command. Okay, so in order to do that, it's an ELF, I guess, sorry, yeah, ELF function. So you need to do read ELF, and we need to give S, I guess, and we need to give this library, that is the Linux library, and read ELF, because this file format is a bit different, I guess. So in order to read it, you need to read ELF, because that's a ELF file or something. So what we can do is, we can pipe it with grep, and that is at system. So add system is the one which you are looking for the system command. So if you do that, okay, we do not get anything. I think it's system at, my bad. I think it's system and add. Yeah. So this is the one which you are looking for, not this LIBC system, the system at over here. Okay, you do not need to know all these parameters over here. What's important is this particular thing present over here. So this is the hex value of that. So let's just copy this thing, or you can copy the address of this itself. Okay, so let's just copy that into the cherry tree, and probably you can enter the address as this. We got the system address, and obviously the system address would not change now, because we're not running it. We are checking the location of the system file in this library. In this particular library, obviously, now suppose just for a small example, consider the word list comment txt. On the 3000 line, you'll probably have some word which says www. So that is what we are checking over here for system, in short. Okay, so this is what we are doing. We are not trying to check out we are just trying to check out the location on which the system would be present once we execute this LIBC library. So we get that this, and also we'll be using the same command over here to get the exit function. Exit is not important, it is optional, but to exit the shell properly, otherwise it would give an error or something like our segmentation for. So let's just do that. We get multiple exit commands, but what we are looking for is this exit over here. Okay, so 139, I guess. So let's just copy this thing as well. 3320. So we have this thing copied over here. Now we require bin sh, and for bin sh it's a bit different because it's not a function, it's a string. So it's not a system function or it's not an exit function, so it's a bit different. And for that you have to use the strings command, and you have to give these a and t and x switch so that you can properly get that output in readable format, I guess. And then we can use the library, same library libc, because all these things have to be present in the libc in order to successfully execute the libc attack. We can use grep over here, and we can use bin sh. Let's see if it works. So we do get it. We get this particular address over here. Let's just paste it. So we get all these addresses, and over here it should probably be like 8 bytes over here, but over here it's 6 bytes. So let's just add these zeros over here, because obviously before the number if you add 0, that does not, it's not important, right? So let's just add that because it will be useful later on. So we added these things over here. Now we need to successfully craft the libc attack. Now obviously what we need to do is we get the start location. Let's just consider this as a start location of libc, that is this particular location which we saw earlier. Okay, now obviously you guys maybe be like, hey, the libc value always changes, but why is this value obviously same? As I mentioned earlier, that obviously this is these things, bin sh, system and exit is present inside libc. So that's the location from the libc start point. Okay, so now just consider this thing over here. So libc is present, okay, over here at the start, libc start. Just consider for this example, ignore that, you know, the libc value is changing over here. Ignore that. Just consider ASLR is disabled. Okay, we have libc start location, that is 200. Just consider this locations now, and just ignore these things for now. Just ignore it just to understand it properly. We have libc location over here. We have the bin sh, that is 300, like from the start of the file. Okay, we have libc on the 300 line, 300 meters line, so there is bin sh present, and around 400 meter line there is exit function present, and 500 meter line system function is present. So in short, whenever you load any module, this will load as it is. Okay, my bad. So this, if ASLR is present, so first probably it will start with like 0 meter libc, and respectively after 100 meter this bin sh present. So bin sh memory would be 100 meters, okay, and this would be 200 and 300, so on. In short, the starting point is the libc over here, this libc over here. So we have libc present over here. If ASLR is on, probably it will go like 200, probably then it will go 100, probably it will go 300, okay, then system would obviously be 600. So in short, wherever this entire library will go, the address inside would be same, okay, only the address outside would be different. So what we'll try to do now is, we'll just take a reference point. Just consider we're taking a reference point of 100 libc start. So this is the reference point which we get. So now what we'll try to just have this over here in this file, libc start reference. We can just paste this particular thing over here, and then we can do system address from libc start. Okay, so that is this particular address. Okay, and probably we can just enter 0 and x to represent the hexadecimal value. And now what we'll try to do is, we can enter bin sh address from libc start. Okay, for now, just for one thing, just consider this to be 0. Just consider this is the starting location 0. From 0 till this location, sorry, from 0 system address comes at this particular location. Just consider that for now. Just consider this. And we have bin sh present over here. Let's just copy that. If it may be a bit difficult to understand. If you all have any comments, you all can ask comments below. Sorry, if you all have any queries. And we have exit function over here, so let's just do that as well. Exit address from libc start. Okay, so in short what it says, now just consider this one thing, this buffer.txt file is the libc start reference. Okay, that's the file present. This, now where is the system address over here? It's at location number 6. Okay, and where is the bin sh? It's at location number 7. Where is exit? It's at location number 8. So this is what it is. In the libc library, the location from the start till system address location from the start of libc is this in hex, and it is this for bin sh, and it is this particular thing for exit. Okay, so this is what it is for system, bin and exit. So in order to execute this attack properly, we have this print thing done, right? And then later on we need to add, okay, let's just look into this thing. In order to execute this attack successfully, we have 112, that is, garbage characters. So that means like junk characters. We do not require that. We just need it to be present so that it helps us in buffer overflow. What's interesting is this B4. So which value will come over here is the system value. So system location will come over here from libc, okay, and then it would be exit. I know it's a bit confusing and tricky because I was wondering over here as well why exit comes, but I'll just tell you all in some time. And then we'll be entering the bin sh. So in short, first this thing will overflow it, okay, obviously it will come, and system will be written to the EIP. Since we had written B, right, B, if you saw over here earlier, we had written A, okay, my bad. Yeah, so we had written B over here, right, earlier. So in short, we got access, we got this BBB present. So on the EIP, now we need the system's location on the EIP. So that is why this address is present. That means over here when we go, okay, so EIP, as I mentioned earlier, right, EIP will go to system, and then system needs a command or something, right? Then it's going to go to bin sh. It's not going to go to exit because that's how it would work in the memory stack. After bin sh, if you close it, it will go to exit then. But the format would be this. If you want, you can go and read more on that, but this is how it works. So that's why from system, the command executed would be this, bin sh, memory location. That's why you're giving that. And after you close bin sh, it's going to go to exit. So this is what it is, and this is what we have to frame our payload as. Okay. Now we get the libc start, we get this address and this. So now all these things are present in libc as a standalone when it is not running in a memory. It is just present. Okay, because over here itself we just use this read elf and strings. We do not run anything. So in short, what we need to do now is we need to have a reference point present over here, start reference, which we took this particular location. So when you execute, okay, when we use this LDD, when we use this particular LDD grep libc, so it gave us multiple addresses, right? That means we are executing this file and libc library is being used, but the location of the libc is changing every time. So once we consider this as a reference, we'll consider that as a reference now as well. So what we'll try to do is we'll just use 0 x, okay, let's just copy it from here itself. Let's just copy this and use this particular location. So this is the reference point of the memory for now. Just consider that ASLR is disabled on the target machine. I know it's enabled. We'll look into that, how we are going to overcome ASLR. Just consider for now ASLR is disabled. This is the memory location where, offset location where this libc is starting always. libc is present. Now if you want to consider system address from libc start, so this was the address as a standalone. But if the LIBC reference, okay, just consider first it was 0, and this what it is, probably it is 0 plus this particular address. Obviously 0 plus this is going to be the same value over here. So now if this particular value changes to this, so what would happen to this system address? System address value as well will change. So this, and it will be plus LIBC memory location. That is this particular thing. Okay, then we'll get the actual system address on the memory. So system address on the memory would be addition of this and addition of this. Why? Because now the LIBC memory location has changed. Before it was 0, that means this was fine. But now this has increased, this has changed to this thing. You know, I'll explain it further over here. So if we see this, just remove this thing. Okay, let's just consider this LIBC. First it was 0, bin sh location was 200, exit was 100 and exit was 200 and system was 200 from LIBC start. Now if the LIBC address itself, start address, changes to 200, so this bin sh which was 100 before, we have to add 200, right? Because 200 is the LIBC location now. Before it was 0, so it was 100, right? 100 plus 0 is 100. But now if it goes to 200 LIBC, so that means the location of this bin sh is going to change, because LIBC start address itself is 200 meters. So now bin sh would be like, it is 100 from LIBC start, but in the memory location it would be 300. If it would go further down to 400, bin sh location would be 500 and 600, 700 respectively for exit and system. So this is how it's going to work, because since LIBC start address changes, see why I'm considering this as a stack, because this is the entire library and this bin sh exit system is present inside this library. So that's why I'm rotating this. This addresses inside would not change, but to the memory outside would change. LIBC is at 100, so this is 200, 300. Yeah. My bad. This is 200 now, so we'll add 200 into the location over here. So this is what we are doing over here as well. So I know it may be a bit hard to understand, but yeah, so this is what it is, and now we have to add another same thing over here as well, and same thing over here below. So we have to add all these addresses with the new LIBC address, which we have taken as a reference considering ASLR is disabled, just for example. Now what we need to add these values, to make it easy, you can go and check out the hex editor online, hex addition online, and you can do it, but we can do it with Python code as well. So let's just create hex add py, simple Python code we can create. Bin user, I think it's user bin Python 3. We can add two numbers. We can add a, that is this particular LIBC reference address. We can add that, and we need to add it in this format itself, okay, hex format. We need to add other location is this system, b is equals to this, okay, and then we add bin sh as well. We can add that. We can give that variable c, and we can, obviously you can give the actual variable, that is exit as well, but just to keep it simple, okay, let's just do that maybe, and d over here. Okay, so we have this. First is the LIBC, then is the system address, then it's bin sh, and then it's exit address. Okay, so what we can do is we can just add each. So first we'll be adding and we'll be printing it as hex. If we do not use hex over here, it's going to actually print out the decimal value. So we need to use hex over here. So we give hex, and first thing we need to add system with the LIBC reference location. That means over here it will be add B first and then A. You can obviously add AB, but I'm just saying this, this is the system address, this is the LIBC address. So we can do that and print it. Then we can print the other one. We can just copy this for now. Then we can print C, that is the second one, that is your bin sh. We can print that over. Okay, so then we can print D, that is your exit address. So we can print that as well. So this is what it is, and let's just try to run it. First, I think we'll have to chmod it and then run it. Chmod 777. Okay, don't give 77. My bad. Just do 744 and hex add dot py. Can give that. Okay. Now try to run this using Python 3 hex add dot py. And we get the addition done over here. Obviously you can make it better, you can write this exit value, system value, bin sh, but since we understand what it is, so let's just leave it as it is. Let's just copy this. First is the system address location, which we got is this. Then we have to write this particular thing over here, that is the bin sh address. Then we get another address, that is the system address. My bad, this I have just considered system. I am not sure why I did that. It should be bin sh since I just copy pasted. My bad. So this is what it is. This is the address over here. Let's just once cross check 40310, right? Okay, and over here also we mentioned the same thing, 403 162 BAC 162 BAC 33260 okay, that's correct. So obviously just try to confirm and see. That's why I always copy paste rather than typing it manually. Okay, so we have this location as well, B75CB00. So let's just check that as well. Okay, now we get all these locations present over here. Okay, now we'll try to modify this thing one by one. So what we'll try to do is we can use this Python print, okay, and we can try to use all these addresses one by one. So since we have okay, so we'll just use this particular address first, and to give this address first we need to give the system address, right? So that is this particular thing. You cannot copy it directly like that. You have to give it in a bit different way, that is this /x, and we have to start backwards. In order to write the buffer overflow, you have to write this thing backwards in a reverse order, and that's what we are going to do now. So if you write in the correct order, it's not going to work. So reverse that does not mean 0, 1, 3, okay? Just consider these bytes first, because that's how it's going to write in the reverse order way. So we'll give these bytes first, then we'll give this, then we'll give 60, then we'll give 60, then we'll give B7. So that's what we are going to do. Make sure you don't error out. We can write B3, then we can give 60. My bad, we have to give X B3, then we can give X 60, then X B7. Okay, so that's what we got over here. And now the exit address, so that is this. We can give this particular thing over here, X60, then E2 Xe2, and we have 5F, X5F, and then we have XB7. Obviously you don't have to add the 0x, B7. Okay, so you got this done. Now we need to change this, bin sh. So let's just do that. Bin sh address is this. So we'll be having AC first, AC, then we'll be giving DB, XDB, then we'll be giving 72, X72, and also we'll be giving B7, xb7. Okay, so we give this, we'll just try to print it in our target machine and see if it works without any error. First thing, so it did work. Obviously, just ignore this thing, it's not going to display it properly, so let's just ignore that. I think it is going to work in this. So now we have written, now we have written the entire code over here which we are going to execute. In short, we got that system, right? System was present, we got this thing, and this is system, this is, then it's going to go to bin sh, then it's going to go to exit. So this is how it works, as I explained earlier as well. So we got this command. So but this is entire code is only valid if the libc address is this 75cb00. But we saw earlier, right, 75cb00 came once itself and then it was randomizing. So you got a different address. Now that brute force will come into picture over here. So in short, if we add this particular thing, we'll probably get a segment fault error. So let's just try that first. Use that dollar sign, and also over here close this thing. We'll copy it. We'll use that overflow. Where did it go? User local bin overflow, and then we'll paste this thing. We got a segmentation fault error. So obviously we will get a segmentation fault error because that libc address over here was maybe different. So what we'll try to do is we'll write a for loop over here, not for loop, do while loop. So we'll just write as while true, do this thing, and done. So this is what we are going to do, but we are going to put it in one line itself. So okay, so we have to do that overflow as well. So we'll just copy this, paste it over here. In short, what we are trying to do is to understand this better. Since we tried to execute this, right? So in this, the address is this. So we got segmentation fault because obviously that address did not match libc, and it just consider that, hey, this is not some system address, this is not some exit address, this is not some bin address, bin sh. So it just considered some garbage value or something, some chunk value, and then it was like, okay, it's that's why segmentation fault. So we'll try to brute force it. That's so that, maybe we try to brute force it once, twice. We'll try to write a do while loop. So what it's going to do is it's going to keep executing this with this particular, command, which is the reference point is this particular thing. So when we try to brute force, if you consider randomizing a number between 0 to 10, okay, if you maybe at after 10 times, okay, maybe at 10 times you got all unique values. Okay, like first you got like 7, then you got like 5, but probably after the 10th time you will get a same value, right? You will probably get 7 again. So this is what we are trying to do. When you are randomizing 0 to 10, at one point of time obviously you'll get the same number, that is 7 probably, if you keep executing it more than 10 times. So this is what we are trying to do over here. We are just hoping that, at once this brute force ASLR address would probably match with this address. This is what we are trying to do over here. So I just take that, copy it, and paste it over here and see if it works without any errors. So it's going to say the segmentation fault. It's going to keep running for a long time. It may take some time to execute. And obviously if you might have made some error in the memory address or something, then it may give us an error, but we'll just see, hope for the best. So this is trying all possible values, maybe ASLR values like 1, 2, 3, whatever this particular hex value over here. We are not trying to brute force it, we are just trying to run it using do while loop, hoping that at one point of time we'll probably get something over here. Okay, so if we see over here, it got stuck, right? It's not going to go further than segmentation follow. It's not going further than that. Probably we got our bin sh shell. So if we do who am I, we are over here as root. So if we do lsla, we are obviously over here, we'll go to cd root directory. We do lsla over here, we get our root flag because who are we? We are root. So this is how the exploit worked. And to make it understand better, obviously this thing, just obviously we have this small example over here of 505 memory location itself. So we had written, probably we took a reference point of 200 consider. So just consider this thing as 200 itself, and we took that reference point and we wrote bin sh location that was 300, exit 400, and system 500. So just consider this thing 300, 400, 500. So yeah, whatever it is, yeah, we wrote that location in that particular aspect considering 200 as a reference. So obviously when we use that do while loop to bypass ASLR, we wrote a do while loop that is, it's going to brute force. That's going to be like, I'm going to go 100, I'm going to go I'm going to go to 0, I'm going to go to 100, I'm going to go to 500, 600, 700, 800. It's going to go round and round. But at one point of time, it's going to come back to the same reference point, that is 200. Maybe, because as I mentioned, 0 to 10, if you keep doing a random value, so it's going to come up to one value, right? I hope you guys may be knowing this. Random value, random number generator. Yeah. So if you do max 5, so first we got 2, then we got 5, then we got 3, then we got 2 again. So we had got 2 at first, right? And we got 2 again. So this is what's going to happen, that maybe, obviously memory it's not infinite, right? It's a finite place. And since it's a 32-bit system and we saw that only 3 bytes were changing in between. So I think 256 or 512 possibilities, I guess, of the memory location. So it's going to go randomize. At one point of time, since we took the reference of 200, we are going to get 200 again. That's where everything would match, and this particular thing would become our shellcode over here. I don't know why this thing not getting highlighted. Yeah, so that means it gave the green star to like 200, and that's where this thing got stuck over here and we got the shell. Okay, so I know it's a bit hard to understand, but I try to make it as easy as possible. So if you all have any queries, you can ask in the comments below. And this was the box. Best way to do it is get it into a 32-bit external system like some other system, and I didn't want to install another OS and everything and do this thing. So you can do that and disable ASLR and test out that this command works first, and then you can probably go ahead. But we can go ahead at this way as well. But yeah, I think this was a good video. So good video as in good box. My bad, good box, because you get to understand the Linux buffer overflow better over here. So it's going to help us because buffer overflow is present in an exam as well. So that's why it's a good thing to know, and I don't think this was a very out of scope box for OSCP. Okay, so this was the box. If you guys like the video, do give a thumbs up. If you all have any queries, obviously ask in the comments below, and do subscribe for more upcoming videos. Thank you.